All right, this is the force, work, and power test answers continued for those of you doing the relearning. This question number 3 was just the definitions using the units and the base or the fundamental units of kilograms, meters, and seconds as was given to you in notes and showed to you how that works early on in this little unit. And so the first one, kilograms times meters squared divided by seconds cubed, is power or watts. Kilogram times meter per second squared is a newton, a unit of force. And the kilogram times meter squared per second squared, or a newton meter, is a joule, and that is a unit of work. And on the other version of the test, they were just given to you in a different order, the same way. The first one was newtons, the second one was watts for power, and the third one was joules for work. All right, as far as the last question goes, all right, in this one you're given some information about a water bottle just like yours that rotated 10 times, lifting a mass of 40 grams, and you were asked for the work. All right, so the work comes from the force times distance equation, and we can find the force, which is the mass in kilograms, times the acceleration in gravity, which is 3.92 newtons. Now we need to find the distance. What you need to recognize in this question, I gave you the radius, 1.3 centimeters, and the string is attached to the bottleneck just like you had yours. And every time that bottle rotates one time, the string has been wrapped up a distance equal to one circumference of the bottleneck. So the value for figuring out the circumference is pi times 2 times the radius, or pi times diameter, which in this case comes out to be pi times 2 times 1.3 centimeters is 8.168 centimeters. But there were 10 rotations given to you in the question. It rotated 10 times, so the distance the mass was lifted would have been 10 times the 8.168 centimeters. So rotations cancel out, or equal to 81.68 centimeters. But recall that our distance has to be in meters for the equations as the units are defined. So the 81.68 centimeters is equal to 0.8168 meters, and that's the distance to use in the work equation. So then the work is equal to 3.92 newtons that we found above, times the distance in meters, and you end up with 3.20 joules. And on the other version of the test, same process. He had a different mass. The force was 4.41 newtons, and the only difference also was that this one we said it rotated 11 times, so it was 11 times the 8.168 centimeters, giving you 89.848 centimeters, or 0.89848 meters. So when you put it into the force equation, you have 4.41, the work equation, the force of 4.41, that's supposed to be a newton, times the distance in meters, you get 3.96 joules. Now as you work these out, for this to work, if you're having problems, is you should be pausing the video step by step and working it out to convince yourself that you've got it. All right, thanks, good luck, and good learning.